Good morning. I'm Shweta Bangalore Harish, and today I'm here to talk about uh, the project that we did as part of Secure Programming for Application Development module. The exercise involved reviewing the set of code that our professor provided us and to research on the best practices, tools, and technologies and programming paradigm that the industry uses as of now. I would like to mention the programming paradigms roughly that we have researched upon. Broadly, there are two kinds, that is imperative programming paradigm and the declarative programming paradigm. And in imperative programming paradigm, we have programming concepts such as procedural programming paradigm, object-oriented programming, parallel processing approach. While when we look at the declarative programming paradigm, we have logical programming paradigm, functional programming, as well as a database processing approach. Now, in this review or in this research that we're doing, we are going to be comparing the types of paradigms that are used and that we're supposed to use and which goes in line with our project. While we've been introduced with different kinds of programming paradigms, it is up to us to select which kind of programming paradigm we are supposed to go, which is in line with the architecture that we are using, the design that we are using. Most of the times, imperative programming is what people use. That is the procedural programming paradigm that is traditionally used. But when it comes to security, I think we're supposed to be using something called as the functional programming paradigm. A lot of times, object-oriented programming is essential. This is when we're supposed to create a graphical user interface, while the functional programming seems to be more useful to that to the programs that require high level of reliability and security. While performing research regarding types of testing, we have come across that there are variety of testing techniques, of which two are very important. Those are static application testing, security testing, and dynamic application security testing. Apart from this, there is something called as hybrid application security testing, which is a combination, basically a combination of these two. And while the testing process, while we're talking about the testing process, it is mandatory to mention few important points such as network security, system software security, client-side application security, as well as server-side application security. There are multiple tools and technologies that have come up with ideas on how how security can be integrated with these aspects. And in addition to these two main testing processes, we can also consider something called as penetration testing, wherein we simulate attacks on the system so that we can know the vulnerabilities well beforehand, and compliance testing to check if our architecture or our programming, our development process is in line with the policies. Load testing. This load testing actually helps us identify if there are any sort of attacks that are happening. And origin analysis to know from where we're downloading is an authentic place or not. For the project code that we have been provided, we have performed static analysis. We have made use of two ways of testing, that is well-known approach-based testing, that is the static testing that we've done, and manual code review as well. In the static testing, I've made use of find bugs extension. I've taken the report from Eclipse IDE as well as IntelliJ IDEA IDE. This what it basically does is it runs the find bug tool against the project code, and it gives all the possible vulnerabilities even before the code is being run. So the advantage of doing the static code analysis, that we need not run the program, or that is we not execute the program, but we just need to have access to the source code, which is true in our case. And manual code review, this is very important because there are a lot of things the tool might not catch. So from what we have learned in the module and from the research, we can identify a lot of manual code. Manually we can find out a lot of errors. Out of which, from the static analysis, we have arrived at a report where there are multiple of errors. Those are malicious code practices, just warnings, as well as there were severe security issues which were related to the database. While in the manual code review, we could find out that there are a couple of loopholes, such as there were no input validations, and the packages were not protected, and things like that. From the manual code review as well as the tool that we've used to perform testing, we can find that there are a lot of fields that have not been made final. That is, strings such as connection strings, which are supposed to be final so that there is no tampering done by any attacker. And there is a lack of use of your prepared statement in view of the files, which could lead to, again, improper inputs can lead to SQL injection. So those are the few errors that we found. And there were few variables that were actually initialized and performed operations on, but they were not used anywhere. This could actually reduce the performance in terms of memory. And there is one error wherein they're using double equal to operator, instead of which they could just use equals method, which is way more efficient and could avoid buffer overflows. And the packages should be made private because they can be accessed from anywhere outside the program, and any intruder could gain access to them. The major security error that the static analysis tool picked up was that non-constant string passed to execute or add batch method on an SQL statement. This statement, or this string to which an input is passed, could lead to SQL injection, and that is what this tool is showing. And when it comes to things like this, it is always uh, um, prefer to use final variables as well as prepared statements. Apart from these errors, I think there are a lot of other minute but very important errors, wherein we are not um, in validating the input. We're not checking against we're not checking against scripts that can be injected, or compliance towards few policies. And those are the few things I think we could change in the project code so that it becomes a little more secure. These are the few proposed solutions for the errors that we found in the project code. Through this exercise, we have learned that the security needs to be incorporated in every level. We need to concentrate more on defense in-depth mechanisms, and not just in the later parts of the deployment, but initial stages of the software development also needs to concentrate on security. It starts from what paradigm we use, what language you make use of, and at the end of the day, it's not just about the languages that we use or the paradigm that we make use of. It is the basics, such as very basic uh, concepts such as input validation or sanitization or verification. These are the concepts that we need to adhere to, and we need to form policies as well as architect and design our program such that it is in accordance to all of these security elements.